So welcome everyone during our first Lunch and Learn workshop session. So let me quickly present today's presenters. So I'm the host. My name is Lukasz Majer. I'm the marketing director in Novacura, but I'm not the special person today. Let me present our experts. I will start with Emilia. Emilia is our experienced consultant, especially experience in the manufacturing area. And she used to work with ERP systems a lot, especially with IFS applications, and she has a wide knowledge about manufacturing processes. Unfortunately, she will not present too much today, but she's here to support us, if you have more specific questions or any other questions regarding manufacturing, other than directly related to the topic that we will bring up today. And to be honest, she decided to participate when she realized that I'll be a host today. So she felt that it's better if I have some, real support here. So that's why she is watching me now. And I'm happy to present Lloyd Briggs, our Englishman in Norway. Lloyd works in Novacura from Norway. He is a product owner and he has also experience in manufacturing, but now is working on some technology solutions, especially connected to the topic that we will present today.
Thank you, Lukasz. Yes, so my name is Lloyd Briggs. I'm a product owner for Novacura. I've worked for Novacura for about 2 years, but prior to that, I have experience in general engineering and the automotive industry. So today I'm going to introduce you to computer vision in regards to AI, object detection mainly. So yeah, let's have a look at the agenda. I'm just going to make sure that I can click the screen and get to the next slide. And I can't, I don't think. Oh, there we go. So the agenda today is we're going to look at some business drivers. We're going to look at what AI is and how it relates to computer vision, some use cases. We're going to look at how computer vision models are created. Oops. We're going to look at some examples, some information about how it works on the edge. We're going to look at some of the downstream concepts, so what you can use that information for from the computer vision. And we're going to jump into some questions and answers. It seems quite a short agenda, but trust me, it'll be quite intense. So let's get started. I go to the next slide. There we go. So drivers for AI. What are the business drivers? Let's have a look. So drivers for AI for your business could be, wanting to improve your customer experience. It could be reducing scrap, reducing cost, improving quality, growing revenue, improving safety. You could be augmenting or automating complex tasks or repetitive tasks. Now, what the drivers are for your business is very specific to your type of manufacturing company, but simple things like reducing cost by improving your quality with automated systems in total improves your customer experience because you're improving your quality throughout the business. And that obviously increases revenue. If you can improve your quality, you can produce more. You don't have to do any reworks or any extra work to make the product. So obviously you're going to increase your revenue. So there's lots of drivers for your business, but we'll take a look at some of these going forward. So we'll go to the next slide. We jumped 2 slides there. Can you go back, Lukasz, 1? I'm struggling with your controls. There we go. Okay, so CIOs are switching on to AI, according to Gartner, and these are the results. So how many organizations are planning to implement AI within their business? How many aren't interested? And how many will likely implement it in the short to medium term, in the next year, 12 months, to the next 2 years, to the next 3 years for some more longer term planning? And how many have already implemented AI in the business? And you can see quite clearly that's a minority that have no interest at all in artificial intelligence in their organizations. A small percentage have already implemented some AI, but increasingly, as you can see, there's a trend for organizations to implement AI within their business and their organizations to reduce, whether it be cost or improving efficiency of various ways. You can implement AI. So as we can see here, the trend is upwards for AI. So what are the challenges to delivering AI within a business? There are various challenges, and one of them is quite simply the staff and the skills of the staff in your business. Do they understand what AI is? Can they implement it? What does it mean for them? Do they need training? How do you go about from having zero AI to having AI when no one in your business has any skills? That can be seen as a barrier to implementing AI. It could be understanding the benefits, quantifying the savings that AI provides to your organization or your business when you haven't had AI before. It can be challenging to understand the return on the investment. It could be the data quality and quantity. You may not trust AI's data. You may have misgivings about its quality or how the data is produced. You could have trouble finding a strategy to implement AI and having the right partner around to help you with that. That's definitely a big challenge for businesses, because how do you get started? That can just be the most challenging question. And integration, how do you implement AI with your integrate AI with your current business infrastructure? It could be your ERP systems, your machinery on the shop floor. It could be various systems in your business. How does AI connect to those systems and work with those systems? So we'll go through some of these challenges as we go through the presentation, but keep them in mind and have a think about how these challenges and which of these challenges you have in your own business. So let's take a look at what is AI and what is machine learning and what is deep learning in regards to computer vision for us in this presentation. So artificial intelligence is very simply a technique which enables a computer to mimic human behavior, repetitive tasks, for example. You've probably seen or had experience with these automated telephones where they listen to your responses when you're in an automated menu system, and you have to talk and you get frustrated because it doesn't understand your language or your accent. These are typically using AI. And within AI, you have machine learning, which gives AI a bit of an edge. It allows it to learn from experience. Thinking of how a child learns as it grows from doing tasks and repeating tasks. AI, machine learning and AI work together to produce a better AI model by rehearsing and learning from new experiences. And then you have deep learning, which is again a subset of machine learning and artificial intelligence, which allows neural networks to be used for the artificial intelligence, which allows almost instantaneous results, and it enhances the machine learning concept even further. And within deep learning, we have computer vision. So computer vision has been around for a while, and you've probably heard or seen about it in the news, about facial recognition, being able to detect vehicles on roads to count how many trucks or vehicles are going down a road at a given time of the day. Various ways you've seen computer vision in your real life now. But let's take a look at it, how it relates to manufacturing. So let's take a look, first of all, at what computer vision is and with AI. So there's two main computer vision types. You've got image classification and object detection. With image classification, it's quite one of the most simplest forms of computer vision. It literally will detect and define an image based on what it sees. So if you have an image of a cat and the model is trained to detect animals, and if it sees a cat, it will say this image is of a cat. Very simplistically. It will not tell you if you've got a cat and a dog in the screen. It will not tell you, it will not be able to track those objects as they move. It literally will just classify the image as you define in the model. And then you have object detection. Object detection, which is what we're mainly going to focus on in this presentation, allows you to detect multiple objects in a screen or in a video. It allows you to track those images, also those objects as they move throughout the video. And it gives you outputs of those results in real time. So you can imagine being able to track people walking around in a shop floor. You can build analytics and things like that from that kind of data. So let's have a look at some of the use cases. So object detection. The main use cases will be, anomaly detection, detecting anomalies in products. It could be quality inspection, looking for defects. It could be safety, tracking people with hard hats in a given area, making sure they have hard hats on. Automation, analytics, for example, if you have a space and you want to see how many people are moving around that space and where they're moving around in that space. Zone management and access control. You've probably all been through those passport gates at an airport where it scans your passport and it tries to look at your face and recognize your face and compare it with the biometrics on your passport. There's various ways that object detection is used in the real world, but these are the most common use cases that we find. We're mainly focusing on the manufacturing side in these slides, so don't worry, we're not going to look at access control in this analytics in this slide deck. So let's have a look at the differences between object detection and classification in a real example. So this is an object detection example. In this video, what you'll see is a conveyor belt with products moving down the conveyor. We have a predefined price list for these products, and as the video camera detects each object, it's going to say this is this object, and it's going to add the price to a total in the top left of the screen. Just to give you an overview of how object detection works in the process, we capture each frame from the video, we buffer those frames, and we perform inference on those frames. Inference is the AI section, the deep learning algorithm model that's trained to look at these objects, and then it produces a result outwards, which you'll see in this video. I'm just going to press play now. Oops, it went back forward. Okay. Lukasz, I can't press the play button. Can you do that for me, please? Thank you. As you can see, you've got various products moving down the screen. And I don't know about yourself, but you can see all the products are all switched together, upside down, not arranged. Doesn't matter, the camera can detect them in various positions based on how you've trained the model. And we'll look at the model section in a moment. But as you can see, it's identified every product on that conveyor belt and create a total at the end. That's a very simplistic example of object detection. It's detecting multiple objects, multiple products, identifying them, and producing the price that matches that product on the screen. Okay. So let's have a look at image classification. I am not able to press the button now, Lukasz. There we go. So with image classification, it's a bit different. In this example, this is a real life example. We have a silo of liquid mixed with various aggregates. It's a very abrasive material. Originally, the customer had sensors within this silo, and these sensors would degrade very quickly because of the abrasive nature of the chemicals and liquids in this tank. So they wanted a way to detect whether the silo was overflowing or not. And if we just play this video now, there we go. As you can see that the top left of the screen, it says the tank is low. And as the tank fills up, that classification is changing to high. So we're detecting the whole image and saying, is the tank full or not? And as it's filling up, you can see it's high and it's overflowing. And the classification changes as the tank reduces again. Now, in the past, what would happen is if that sensor had failed in that tank and someone would have to go into that tank and replace it, they have to drain the whole tank, clean it out. Someone have to go in there, replace the wiring, cabling, and the sensor, back out again and fill the tank up. That would take several hours, potentially a whole half of a shift. So that would be downtime that the customer suffered from that experience. But with this camera, which could be monitoring multiple tanks, you can easily identify the situation in the tank without having to ever have to enter that tank and go in and replace any sensors. This camera is an outdoor camera designed to work outdoors. It's got a self-cleaning lens. It doesn't need to be maintained. It just works day or night with this AI image classification. Okay. So how do you create computer vision models? I mentioned earlier that we train the model to identify objects. Let's take a look at how that works. So it sounds complicated, but it's actually one of the most easiest processes you can do with AI. First of all, you need to know what objects you want to detect. For example, if it's cans of soda moving down a production line, what we need to do is take pictures, gather videos or pictures of those products moving down the conveyor. We would then annotate those images, and then we would use the deep learning AI algorithm to train the model based on those images that you've annotated, which has no user interaction. You just start the model to train. It can take some time for the services to run and train the model, but that's all handled for you by the software. There's no human interaction on the training the model aspect. So after that, you can review your model performance. If it's satisfactory, if you're getting, for example, a 95% accuracy on your detection, you say, okay, but I want 99%. You can then go back, add some more, annotate some more images, add some more images, and train the model again. And as an iterative process, review the performance, and you can increase your performance and accuracy each time you add more data. Like as I mentioned before, as a child learns more, it can do tasks better. It's the same with AI. An example of the annotation process we can see here. You can see that we have some boxes drawn on an image. Those boxes, there's 3 of them. One, the red box is selected around the truck. The blue box is around a valve in its open position, and the green box is around the hose connected. So what the person here is doing is they're training the model, or sorry, annotating the image to show the objects that we want to look for. In this case, it's the truck, whether the valve is open, and whether the hose is connected. And the position of these boxes, which are just drawn with a mouse cursor, is important because that tells the algorithm what to look for, what in the image to try and find. So, okay, let's say I've annotated 100 images. What does that look like when you run it through a model? Well, we can see here. In this example, actually, there is a camera monitoring the back of these chemical trucks, because there are incidents where if a driver operates the back of this truck, the valves in the incorrect order, there could be a leak, and that leak could cause injury or death. So this is a very serious use case. It's for health and safety, making sure that the hoses are connected in the right order and the valves are opened and closed in the correct order. And if this camera detects that something hasn't happened in the correct order, an alarm, an audible alarm sounds in the area of this truck. So let's play this video. So we can detect the valve in a closed position, the hose is connected in real time. The operator is connecting the hose. Hose is now connected, the valve is now open. And the sequence repeats for every truck that comes and goes. So if an operator detaches something or opens a valve in the wrong order, an alarm sounds. But you can get the idea. This is using AI object detection to improve the safety compliance within this organization, within this customer. Because the risk of operators making a mistake in this situation can be, it can put lives at risk. So let's look at some other examples of object detection. So here we have an example from BMW. They're using object detection in a few parts of their manufacturing process. The first section, which you'll see in a moment, they're using AI to detect the combination of badges that can be on the car, designating the model and the drivetrain. So X drive and the combination of 440i. These combinations can only be used in certain fittings of the car. So they're using AI to detect those badges and warn if those badges are implemented on the wrong vehicle or the wrong order. They're also using AI in the press shop to identify defects in the metal. And they're also using it in the trim to make sure that the bonnet and the body, the gaps between the bonnet and the body are within specification. Can you play that video for me, Lukasz? Oh, I've got it. Thank you. So first thing that happens is their staff members take pictures of each model to build up the annotation database, as we mentioned earlier. This is the annotating happening here. So he's saying, okay, this is X drive, it's a 440i. Build up a huge data set of images. And now the AI model can work. So the camera on the shop floor is capturing each combination and checking. In the press shop here, you can see that they're producing panels for the body for your BMW car. And what can happen in this process is you can easily get microfractures. And they're using infrared cameras here to detect microfractures at certain key points of the press panel. They're looking for a particular size of defect that's out of spec. So annotating those images, gathering that data, using the neural network, the AI model will identify whether this crack or defect is within or without spec. And if it's out of spec, an operator will be notified and they can reject that panel or remove it from the process. So that panel's been rejected because it's out of spec. An operator doesn't have to check each panel with his own eyes anymore. He doesn't have to stand there all day and looking at panels. And this, on the production line, on the trim line, you can see here that identifying the distance and measurements of gaps between the body panels. If the gap is too big, then that car will be put onto the rework line, because that car cannot go to a customer if the quality specifications haven't been met. Again, that's improving the quality for the customer, reducing the fact that that car will ever go out to a customer and have it being recalled because of these issues. So it's improving the process, and it's allowing their employees to work in different areas, not focusing on repetitive tasks, which can be prone to human error as well. So object detection, they're working on quality mainly, but let's have a look at how it can be used in more of a logistics sense. So in this concept, we have trains moving down a filling station, train cars moving down a filling station. And the customer in this regard needs to know which train, which code on each car is being filled and when, so that they can track this going forward in the logistics to see which car got filled when and what date and where. So I'll just play this video. So in this object detection example, you can see that it's not only detecting the train, it's detecting the characters printed on the train car. Those characters are stored in the database, as you can see, it's printed on the top left of the screen, and they're combined and compared with their ERP system to show which car is being filled. So it's using object detection to detect the characters and OCR to read the characters in real time. So the use case for this is very simple. It's just tracking of filled cars, because those cars can be attached to other trains or disconnected at different parts of the production process. So this makes sure the customer knows which car is where and when it was filled. Okay. So, oops. Just go to the next slide. So, edge video analysis. Let's have a look at what edge video analysis is. So, how were all those models, how is the camera detecting all those things in real time? How is it working? Well, the cameras themselves, it's just a sensor, just a camera sensor. We all have them on our mobile phones, but what's important is the hardware behind them. So in these first two pictures here, the self-cleaning AI camera and the indoor AI camera, within them is actually an embedded compute unit, an NVIDIA Edge compute module with a GPU. It is passively cooled. It's powered just from an Ethernet cable, but that device is doing all of the real-time video analysis, whether it's just detecting objects and performing OCR, tracking objects as they move. These devices are doing all of that within the unit itself. There's no hardware anywhere else in the process. It's just these devices. these cameras. They have various capabilities as well. They have, the software embedded within them, so there's no external software required. They're just, like I say, powered over the Ethernet, and they have GPIO connectivity. So if they need to talk to your PLCs or to your manufacturing equipment or to your to have any alarms, these can all provide that with just the camera alone. And they roughly cost around $700 as a hardware as a service. So how does that work in a wider sense with your ERP system? Well, firstly, you have your camera, which could be detecting products on a conveyor belt in this example. Then you have the embedded AI module, which is doing all of the processing. So as it's detecting objects, for example, in this case, if you want to reject a product off a conveyor belt immediately based on the result in real time, without waiting for having any delays or waiting for an external system to tell you to do something, you can literally just have the camera itself talk directly to your PLC or to a relay station, and that can reject the product immediately. So the camera can go direct to your PLC in a communication. And it can also notify your ERP system using Novacura Flow. If your ERP system is in the cloud, or your manufacturing system is in the cloud, you can use Novacura Flow to communicate and perform transactions. It could just be updating an inventory count, it could be counting parts, it could be analytics, it could be backflushing product. So this information doesn't just go one way, it can go both. So downstream concepts. So what do we talk, when we have AI, how can we use the data from it? What does it do? So as I just saw there, you've got various ways you can talk to your PLC, you can talk to your ERP system. Data from that AI can also be stored for analytical purposes. It can have real-time alerts. There's various ways that you can use the data from your camera, from your AI engine. And it's really very specific to each customer and each use case, how they want to use that. In this example here on the left, you see a very happy guy here, and he's using an AI camera just to detect in health and safety concepts whether someone has a hard hat on or not in an environment. Let me just see if I can play this. Here we go. So you can see here that he has a hard hat on. As he takes it off, alarm sounds because the camera is detecting whether the hard hat is on or not. And this technology is actually being used in construction environments or hazardous environments to enforce compliance of health and safety, because it's cheaper to have this camera doing that than have someone be injured or lose their life potentially, and for a company. So real-time alerts, information for analytics, communication with machinery and cloud systems. These cameras can do it all. AI can do it all. So that kind of runs up, that kind of finishes off where we are with computer vision and object detection. We've looked at some use cases, some examples, and I hope you've had a chance to think about how you can use it or implement it in your own industries, in your own businesses. And, any questions that we can start asking them now, because we can go into any questions you have, but have a think about how AI is if it already exists in your business, and also whether you want to add any additional AI in the future. So passing off to Lukasz here.
Thank you, Lloyd, for fantastic and very inspirational presentation. Even for me, I watched it earlier, and I'm inspired by that. I hope all of us. Yeah, today's presentation is actually to point the areas and to expand your knowledge about this relatively new technology. And we don't want to point specific areas where you could implement in your organization. I know that you come from different businesses, so you probably have different places where you can benefit from this kind of technology. So yeah, but we are here to help you identify it as well. So if you are interested in implementing it, how to start then. So our role in Novacura is, first, we think we can provide some consulting and help you shape the solution and help you identify if it could really work in your case, because we should probably emphasize it. This computer vision will not perform very well in any situation. So there might be some cases where it doesn't provide accurate object detection. So, but we have this knowledge, we have this experience, so we can help you identify it and decide if the case you firstly preliminarily identified is right to implement computer vision. We can also integrate it all. We provide integration engine, and we provide basically Novacura Flow that and we can easily integrate it with ERP system, which is very important, I think, because if this information is integrated, you can count all the statistics, but also make immediate decisions. So for instance, if there are some broken parts detected on the conveyor belt, you can immediately change your daily production plan and plan to produce some more parts that you produce to fix this gap. So it's not only it's not an island, it's now connected to the whole ecosystem of applications that exist in a manufacturing company. So we can help you integrate it with that. And we also rely on partners when it comes to the hardware that exists in the edge, and as we call it, and also specific software. And we have implementation partners that could help you implement these technologies, the specific technologies and this equipment in your company. And we would like to take a role of the whole project coordination, so we can also add some project management to that and help you organize this whole investment. If you are interested in, please firstly contact your local account manager, and these people will definitely provide, redirect you to our specialists, and we will help you organize it if you are interested in. So this is my 5 cents to that presentation, and now it's the actual questions and answers session. Let me check. I got so feel free to ask your questions now. This is the right moment. Do use the chat if you want, or I see one question from you in a chat. If you could please use Q&A. If you can't, then use chat. It's okay. The question is, do you have any example flow you can show where you have used the AI data? So now, Lloyd, to you, or maybe to you, Paul. I think you could tell about it.
I can answer that. Yeah. So the AI data in this use case of object detection, AI data just comes as a normal, as like a JSON payload. So we can consume that data and store it anywhere in your ERP system. It's literally, it would just be a machine workflow, and it would just depend on the data you're receiving, what data you want to use, and that will just be passed into the system of your choice. It could be IFS, for example, or a different ERP system. So the data comes to us in real time. We can batch that data up. We can perform more detailed data gathering. So if you want to compare data between your camera's detection and your backend system, we can do all that in Flow. If you want to see an example, we can take that up separately to this presentation.
I'll just add to that, Lloyd, if that's all right. Hi, I'm
Yep.
Paul Phillips, product manager for Novacura. I think we have some good examples, particular to AI in general, Johan, as well on the marketplace. So in regards to recognizing forms, how to best read data from documentation, and more generic use cases of AI as well. Those can be seen on the marketplace if you'd like to take a look.
There is another question. Do you have additional actually to the first one? Is do you have anything you can show like with scenario? So probably you already responded on that. I think we are not ready to show it now. It's too long for that kind of presentation, or are we?
Yeah, I think for this use case in particular, I mean, the scenarios were BMW that we showcased. There's plenty of others that you can utilize, in regards to our exact scenarios that we're working on right now, Johan. We have customer use cases we're working with. Those are under an NDA, obviously, so we need to keep them a bit more confidential. So, I apologize for that, but that's why we're showing more generic use cases of it today.
Yeah, just to give you some context to that, one of the potential customers, one of the use cases for this is detecting best buy codes on packaging, for food product, to make sure that best buy codes complies with what's on the lot batch in the ERP system, because the operators are typing those best buy codes into a printing machine manually. So the camera will detect and look for first of all whether the best buy code exists, and if not, have an alarm, and if it does exist, making sure that it's the same as the lot batch that started on the production in IFS. I can talk about it, but I can't show you because of the NDA restrictions on that.
Yeah. There is another question from Peter. What is the accuracy of the AI object detection? I guess it yep. might vary in different cases, but yeah.
No, it's actually quite simple. It depends on how much annotation you do. You feed it more and more data, you're going to get, if you have, for example, an object and you have 100 images of that object, you could get a 95 to 99% accuracy. If you feed it another 50 images, another 100 images, you've got a total of 200 images, you could have 99.99% accuracy. There's always room for error, but the more information, the more annotated images it has, the less likely of it ever, not detecting that object. So the accuracy, is just a result of how much time you spend building the annotated images. Roughly, to get like a 99% image accuracy, you need about 8 hours of probably annotating. That's at the very high end, for a real production use case, you're talking about 8 hours of annotating images for one person.
How many pictures do we need then?
That depends on the product, and depends on if you want to make sure it's upside down or not. If it's just always consistently one facing the camera, then it could be a few hundred. If it's more, you're talking a few hundred more. But in general, we say about 8 hours of one person doing annotating for like a model that's production ready.
Not scares me. Okay, there is another question still from Johan. Do you see it, Lloyd? Maybe.
Yeah. So
you can please read it to
yeah,
for the
because. So, okay, Simon, so because you get a signal from a PLC AI, or do you check if there's a file in a directory? I would like to know in a technical Novacura flow step. Okay, so in this use case, we have the shop order number that's in production. We know the machine, we know which operation that is started on that shop order, on that machine, on that resource in IFS. So we compare that. We store in a buffer on the camera the actual lot batch number for that shop order that started, and that is what's used it's stored on the camera, not on Flow. That's what's used, but Flow sends it to the camera. But that's what's used to validate the lot batch number. So hopefully that answers your question. So yeah, so we know which machine it is because we know which camera it is, and we know which operation it is. We know which lot batch, so we can compare quite quickly what's in the machine to what the camera's detecting to the object that's in IFS. Hopefully that answers your question.
Maybe to comment on that, I'm not sure if I'm right in that conclusion, but the most like real-time, the majority of the real-time processing is processed in the edge on the shop floor, and Novacura Flow is just to manage it, to orchestrate
manage
it,
the data between the ERP system and the camera. Yes, the camera standalone, and Flow is integration between your other system.
Because you still need this connection to ERP to compare if this, for instance, this batch number is correct or not. So something has to send this information to the edge part, and that here is where Novacura helps. Without that information, I mean, it has to be online to some extent. Without that information, some of the cases are impossible to do, because what if, I mean, you can detect different objects, but what then? How can you compare it to what is right? So Novacura Flow is to integrate it with the reference database, and then you can compare if the recognized numbers of objects or whatever we recognize is okay, is correct or not. So here is our role. But there are multiple cases. I mean, each case is different. So the balance between what is processed in the edge and what is processed by the Novacura Flow side could vary, in different cases, depending also on how quickly we need to process this information. So if it's very quick, if the very quick reaction is needed, the majority will be at the edge side. If there are more dependencies, but the pace of production is not that fast, I think it will go more to Flow, and then the logic and the reaction will be by the Flow side. So again, case by case analysis needed. One more question. I lost it. Yeah, it's from Albert. Can I integrate it with my current system? I guess probably with the computer. Sorry, not with cameras. Yeah, existing.
Yeah. So I don't see the question actually in my chat, but when you say system, I'm presuming you mean like your machinery or your manufacturing systems. Yes, the cameras have inbuilt logic that can trigger directly to systems on the shop floor. So if it could be a PLC, or it could be a drive on a machine, or it could be a conveyor belt reject station, the camera can talk directly to that without having to wait on a delayed response from your ERP system. So if you want the results from the camera's inference, the detection, then you can have that happen in real time with instant results, rather than waiting for the systems, the layers to be in the middle, causing delays. Especially when you've got high speed manufacturing, you need that instantaneous reaction. So yes, it can connect to various machines, tell us what machine it is, it will work. We can talk to anything, whether it be ERP, manufacturing systems. There's various ways. So that kind of stuff is where Flow shines. If it's directly on the shop floor, the camera talks directly to it. So no problems there. You don't need to buy new machinery or anything like that.
I think it basically answers that question.
Yeah.
I see we have no other questions, so you know how to find us. So if some questions come to your mind later, then feel free to ask and can reach us directly. So look, I think now is a moment where I have my 5 minutes, but not just for me. I hope you see the next slide now. Yes, I changed something in the control, but do you see the intro slides? Can you confirm, Lloyd? Yes, thank you. So yeah, I would like to quickly present you my candidates for the incoming manufacturing lunch and learn sessions. And I was trying to identify the solutions that we provided for manufacturing companies in the past. And I realized that no doubt we've done a lot for manufacturing and logistics in the past. So I prepared a few slides to present some of these. You see, we have something for production planning, quality management, maintenance, safety and compliance management solutions. So for instance, KPI dashboards, OE evaluations. Are you overwhelmed by these? I hope you are. I mean, there is a lot. I don't want to go into details now because we did a lot for just pure production, but production is as good as connected logistics. So again, for logistics, we did the following. We have internal logistics and production support. We have solutions for inventory, pure inventory management like warehousing. We can help you manage the finished goods and shipments and so on, so on. And on top of that, we provide some specific technologies like transportation, exchange, integration, the system called PaceJet, where you can do some kind of quick tendering process and get the best price per your transportation from external transport companies. Or we provide specific technologies that support Industry 4.0 or, as presented today, computer vision. So it's here. You see, this is just a fragment of everything that we can provide for manufacturing companies. Yeah, a little bit marketing in that, but I'm showing it because I believe we in Novacura, we believe that we have a lot more to show in manufacturing because we gathered this experience over the years where we provided, different solutions for different companies, which also means for different types of production. So sometimes discrete production, sometimes contractual production. So very specific, and we mixed this experience, and it's embedded now in our solutions, but also it's like handled by our consultants. So we think, and we selected some candidates for incoming lunch and learn sessions, and let me quickly go through that, and then we will ask you about what is the most interesting for you by inviting you to a survey. So few selected examples. First one, Novacura Flow could be no doubt a bridge to or integration hub for all the machinery you have on the shop floor. So in short words, we can support the Industry 4.0 vision. And we offer the industry IoT integration supporting different protocols. So the conventional like OPC UA or much modern Bluetooth Low Energy, not much modern. I mean, it's different technology for different purposes. We support all of these, and we can then connect to various business systems, not only ERP systems. So this is one case when we can talk about different areas of connectivity, and also about some business cases. Just to point one, when we say industry scales integration, it might mean that you have your scale, as on this picture here, automatically integrated with your barcode reader or any Android device, where we actually automatically retrieve information from the scale and we compare it to some normal weight of, I don't know, maybe 1 meter or 10 feet of cable, and we compare it also the weight the weight and the information about the normal weight. And by doing that, we perfectly know how much cable is on this package. So then we can do the ongoing inventory counting. You have the evidence of what goes to the shop floor and what is returned from the shop floor after the production. So you do it totally automatically because you used IoT and this direct connection with your industry scale. So this is just one example that we can discuss during this session. The second area is that I know it's important only for specific industries like automotive or sometimes food and beverages, where you have returnable packaging. And everyone who works for instance, for automotive industry in a supply chain with all the suppliers, everyone knows that this is one of the most challenging areas in this organization, because single package that is missing could stop your shipment to your customers. So, and they are very specific, and you need specific shape to handle specific components or then specific parts that you produce for your customer. So it's hard to manage to that in a big organization, and we identify the whole process, and I believe we have solutions to manage to that area, especially a portal where supplier or customer and your organization could confirm on a regular basis the number of packages that exist in the loop or in their evidence. So it's a complete solution that we can describe during one of the sessions. The other proposal that we've identified is very generic topic, KPI dashboards or info tables. As you can see right now on the screen, by info table, we mean the kind of big TV screen on the shop floor to present all the KPIs, maybe Kanban boards with all the tasks to be produced for today. So, you know, we can multiply the examples. What is interesting, or what is the most challenging part of it, is not how to present the data, but how to gather it and integrate from different systems, because we have no doubt different sources like MES system, ERP system, production planning system, maintenance systems. And sometimes, to present it right, you need to synchronize this information and retrieve it from various systems to present it on one screen at the same time. Second to last example is just in sequence production customer case, without naming the customer maybe, but we have implemented this very extremely complicated philosophy of production. So just in time, but it's just in sequence, meaning we deliver materials to the production line according to the planned sequence of production. So it's very, very complicated. And to do that, we also have to manage the remote warehouses that are located in different places and calculate the average delivery time to deliver it just in time with that kind of time resolution. I think a really interesting business case. So less technology, more business and processes here, but yeah, one of my favorite candidates. And the last is a complete shop floor reporting package that we have on our marketplace. Again, a part of it is a portal application, but we also have like a mobile application connected to that. It exists in our marketplace. If you're interested in, we can definitely describe it in more details during one of the incoming Lunch and Learn sessions. We'll see you the next time. Thank you.